All right, welcome back from Thanksgiving. We are doing lesson 4.6, putting it all together. So this is picking up, we're kind of reversing what we were doing before Thanksgiving. All right, before Thanksgiving we were given the equation of a rational function and we were drawing the graph of the rational function. Now we're given the graph of the rational function and we want to come up with the equation. Okay. So this is pretty high level stuff, but I'm going to show you how to do it. It's really not bad at all. All right, so we're given this graph. You can see a rational function, a hyperbola here. And we're going to fill in some stuff here, and once we have this stuff filled in, we should be able to come up with the equation. So, first of all, the domain. What x values are no good here? Well, I can see I've got a vertical asymptote at -1. So x is not going to be equal to -1. And then I've also got a hole in the graph at +1. So it's also, x is not going to be equal to +1. For my y values, the range, I can see a horizontal asymptote at +2. So y is not going to be equal to 2. And then again, that hole occurs when y is equal to 3, so I'm not going to get a y value at 3 either. Vertical asymptote, the equation of the vertical asymptote, x equals -1. My horizontal asymptote equation, y equals 2. I don't have a slant asymptote. I will always either, I'll have a horizontal asymptote or a slant asymptote, but I won't have both. X-intercept, it crosses the x-axis at -2, so -2, 0 is my x-intercept. My y-intercept, it crosses the y-axis at +4, so 0, 4. And then I do have a hole here, and it is at 1, 3. Okay. So there's all the information I need. Now it's just a matter of writing my equation. And I know it's going to be rational, so I'm going to put my fraction bar here. I know the hole occurs at when x equals 1, and so remember that's when I have a common factor. So my common factor here, if x is equal to 1, x equals 1, then the factor x minus 1 equals 0, that's my factor. So x minus 1 on top and on bottom, that's going to be a common factor. I'm also going to have issues, my domain for my vertical asymptotes are going to show up. When x equals -1, then x plus 1 equals 0. That's going to be my factor for my vertical asymptote, so x plus 1 here. I've also got, what else do I have here? I've got the x-intercept at -2. Remember, that's going to happen on the top, whatever my x-intercepts are, that's going to be, so x equals -2 gives me x plus 2 for my factor. So x plus 2 here. And then my horizontal asymptote y equals 2. Remember, that's going to be, I've got x squared, right now I've got x squared on top, x squared on the bottom. If I did x squared divided by x squared, I'm going to get y equals 1. And I want it to be y equals 2, so to force it to be 2, I'm simply going to put a 2 up here on top. And now that will do it. F of x equals 2 times x plus 2 times x minus 1 all over x plus 1 and x minus 1. All right, so let's kind of put down how we do this. All right, let's simplify this to construct the equation of a rational function from the graph. What I'm going to do is I'm going to have any x-intercepts on top, x minus an x-intercept on top. Also on top, I'm going to have x minus any holes that occur. On the bottom, I'm going to have x minus any vertical asymptotes. And I'm also going to have x minus any holes to give me that common factor on top and bottom. And then I'm going to say times a on top, where a is equal to either the horizontal asymptote, which we had on the last problem, or if I have a slant asymptote, it'll be the slope of the slant asymptote. All right, so a can stand for either the horizontal asymptote or the slope of the slant asymptote, either one. Okay? All right, so we've got a couple more examples here. Let's do those, and then I'll set you loose on the problems. So this one has a slant asymptote, I can see that. I've got a vertical asymptote at the y-axis. It's not clear because it's on the y-axis, but I do have a vertical asymptote there. So domain x cannot be equal to 0. That's my vertical asymptote. Also, x is not going to be equal to positive 4. My range, I've got all real numbers. All right, even with the hole at positive 3, it does equal positive 3 over here. So from negative infinity to positive infinity, all real numbers for my range. Vertical asymptote, x equals 0. The y-axis is a vertical asymptote. No horizontal asymptote, but I do have a slant asymptote here. And when you have a slant asymptote, it's not going to be a real fancy equation here, but this one is y equals x. It has a y-intercept of 0 plus 0 here. It has a slope of 1. We're going up 1 and over 1 every single time. So y equals x is my slant asymptote. It's going to be a linear function. Y equals mx plus b. My b value is 0. My m is 1. X-intercept, I have two x-intercepts, negative 2, 0 and positive 2, 0. My y-intercept, I have none here because my y-axis is an vertical asymptote. Finally, I do have a hole at 4, 3. Hole at 4, 3. All right. So f of x equals the slope. My a value is going to be 1 because that's the slope of my slant asymptote. So I can put a 1 or not. It doesn't really matter. It's understood to be 1. Okay. On the top, I'm going to have x minus any x-intercepts. So I have x minus a negative 2. It's going to be x plus 2. X minus my other one, positive 2, x minus 2. And then x minus any holes. My x value here is 4. So x minus 4. Okay? That's it for the top. On the bottom, x minus the vertical asymptote. I have vertical asymptote at 0. X minus 0 is just going to be x. And also, that's my only vertical asymptote. And then also x minus the whole, x minus 4. And remember, my a value is 1 here. So my x minus 4s will cancel out here. I'll end up with x plus 2 times x minus 2 over x. And then when I get that x squared divided by x, I'm going to get 1x, and so that's going to be my slant asymptote, y equals x. And that is it for number 2. Alright, so this horizontal asymptote did not come through on the printing, but maybe you can just kind of dash it in here. It should be there at negative 3. Y equals negative 3 is a horizontal asymptote. So let's look at number 3 now. So domain, I clearly have a vertical asymptote at negative 1. X cannot equal negative 1. I also clearly have one at positive 6. For my range, I've got a horizontal asymptote at negative 3. I do not have any holes that I can see. So y is not going to be equal to negative 3. My vertical asymptotes, x equals negative 1, x equals 6. My horizontal asymptote, y equals negative 3. No slant asymptote. X-intercept, I've got an x-intercept at negative 3, 0. I also have one at 2, 0. I have a y-intercept at 0, negative 3. And I have no holes. So there we go. So with that now, let's come up with our equation. Alright, on top I'm going to have x minus my x-intercepts. So x minus negative 3 is going to become x plus 3. X minus 2 is going to also x minus the x-intercept. And then x minus a hole, but I don't have a hole, so I don't have to worry about that. On the bottom, x minus any vertical asymptotes. X minus a negative 1 becomes x plus 1. X minus 6. And then the last thing, I have this, I've got this horizontal asymptote at negative 3. If I left it as is, I would have x squared divided by x squared. That's going to give me a positive 1, and my horizontal asymptote would be positive 1. So to force it to be at negative 3, I'm going to put a negative 3 on top of my fraction here, and now that will work. Okay? So that will do that. All right. If you have any questions, shoot me an email. Otherwise, I'm going to let y'all work on this. We'll have a test over all of Unit 4 on Thursday. Rational function test on Thursday. We'll be reviewing Tuesday and Wednesday. Okay? Hope y'all are doing well. I'll talk to you later. Bye-bye.